So today we're going to be talking about determinants, and then tomorrow we'll discuss what Cramer's rule is. Okay, first of all, a determinant is a numerical value of a square array of numbers. So basically, you can only find the determinant if the matrix is square. That's the second point. So if you don't have a square matrix, you can't find the determinant, you're done.
Like squared or like?
Like it looks like a square. A 2 by 2 would be a square matrix. A 3 by 3 would be a square matrix. So it basically has to have the same numbers going across as it does going down. Okay? And we symbolize it with two vertical lines. They kind of look like absolute value signs. It doesn't mean absolute value, it means the determinant. So if I put vertical lines around a matrix, that means you find the determinant. So let's go ahead and look at an example. The determinant of a 2 by 2 matrix is AD minus BC. Now, if you're wondering where does the A and the D come from, the A and the D are along the first diagonal here. Okay? And the B and the C are along the second diagonal. So basically, you take the first diagonal minus the second diagonal. So we're going to look at an example down here below, how you can find the matrix. Now, first of all, we have to observe this is a square matrix. Okay, it's a 2 by 2. So what am I going to multiply first here? Negative 3 times negative 3. I'm going to multiply that first diagonal, right? And then what I'm going to do is I'm going to multiply the 1 and the negative 1. So basically I'm taking negative 3 times negative 3 minus negative 1 times positive 1. And all you do then is calculate that. Yeah, I mean, it's not hard. You should be able to multiply along that first diagonal and then subtract from that the second diagonal. It should be pretty straightforward. All right. So far, so good? So let's go ahead and have you try for me. Okay? You try on this one. I want you to go ahead and find the determinant for that matrix. Biggest mistake people make is they screw up one of the signs.
6 times and help.
Maybe more.
There's a button on the side.
All right.
Sarah's singing too.
You gotta hear that annoying noise. It's been going on all day.
Okay, answer is 11. Nice job. So how we get 11 is we are going to take first diagonal here. I get negative 3. Okay? Minus this diagonal here, which is negative 14. So negative 3 minus negative 14, you add the opposite. Your answer is 11. All right, you try again. Okay?
No.
Are you going to wear that to Thanksgiving?
Okay, answer is negative 8. All right, we need to look at this one real quick because the 0 sometimes throws people off. So let's go ahead and look at the first diagonal. So along the first diagonal, I'm going to get 0 times 8, which is 0. Okay, minus this diagonal, negative 4 times negative 2 is positive 8. So I end up getting negative 8. Alrighty, so now we're going to look at the determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix. Now there are two ways to do this. There's one way called the expansion by minors, and then there's another way, and we're going to do it the other way. Okay? So first of all, you've got a 3 by 3 matrix here. A, B, C, D, E, F, G, H, I. Now what you're going to do very first is whatever the first two columns are, you're going to repeat. Okay? So whatever the first two columns are, you're just going to rewrite those again. Okay? So you are going to repeat the first column and then repeat the second column. The third column you leave alone. Okay. What?
You don't even include it.
You don't even include the third column again. So now this is what we're going to do. We're going to start here in the top right corner. Okay, I'm going to start here with the letter A. And I'm going to go down a diagonal here. And I'm going to multiply along that diagonal. I'm going to do the same thing with B. I'm going to multiply along that diagonal and get a number. And then I'm going to multiply along this diagonal and get a number. So I've got 3 numbers.
Oh, I see.
Okay.
what you did there.
Now what's going to happen here is you're going to add all those numbers together and get a number. Get a final number for all 3 of those. Now I just did down, right?
You just add them.
Opposite, yep, add the numbers together. Opposite of down is
Oh.
up, but I can't start here with the up on A. Where am I going to start with the up on?
Wait, so G.
G. So I'm going to go this way and I'm going to multiply up. And I'm going to do the same thing. I'm going to multiply along those 3 diagonals. And I'm going to add those together. Once I get those together, to find my final answer, I'm going to take whatever I got going down, and I'm going to subtract whatever I got going up. So you're going to take the purple minus the pink. Now, it's going to kind of look confusing until we look at that first problem, but I think once we look at that first problem, it'll make a little bit better sense. Okay? So let's go ahead and look at a problem right here. Okay? Find the determinant. So we have 2, 6, negative 1, negative 1, negative 3, 0, and 5, 4, 7. So, very first thing, I've got a 3 by 3 matrix. What am I going to do? Repeat the first 2 columns. So go ahead and write those first 2. The biggest thing I can tell you with this is you really have to watch your spacing. If you try to cram them too close together, you're going to have a hard time seeing along those diagonals. So now once we copy those first 2, where do I start? What number will I start here with? The 2. And I'm going to go down. So when I go down, I take 2 times negative 3 times 7. So what is 2 times negative 3 times 7? Negative 42. So I'm going to go ahead, and if you notice, I'm just going to write that number down there. Now I'm going to do the same thing with this diagonal. Now the nice thing about 0, whenever you have 0 along a diagonal, it doesn't matter what you're going to have, you're always going to have 0. Okay, so once you have 0 in there, that's a really easy problem to do. And then let's look at the third one. I have negative 1 times negative 1 times 4. What is that going to be? 4. So now what I'm going to do is add all those up. And what do you get? Negative 38. Okay? So we did the down diagonals. Where do I start next? The 5. And I'm doing the up diagonal. So let's go along the first one. What do you get along that first one? 15. Good job. What do you get on the next one? Oh, for some reason that just, there we go. So I get 0. And then what do I get along that third diagonal? Negative 42. I'm going to go ahead now and add all those together. And what do you get? negative 27 down. Now, do we remember our final answer has to take the form of down minus up? So the down was negative 38 minus the up, which is negative 27. Two negatives there make a positive, and so your final answer is negative 11. Okay. Down minus up, you got to remember that. So we're going to go ahead and look at another one. This one you're going to do for me, though. It's going to take a little bit of time, but I think you can handle it. Okay? So first thing you got to do is add those two extra columns.
That's negative. So you subtract
What?
Okay, did we go ahead and enter them in? Yep, enter them in if you got a solution. Yep. Okay, so let's go ahead and see. 20, nice job. Actually, we did better on the 3x3 than we did on the 2x2s. So, nice job. Okay?
And then 2x2s?
Yeah, the 2x2s we actually had a higher percentage. So, this is what you need to do. Okay, you need to go in your book to page 195. So, page 195. Page 195, you need to do for me 26 through 37. Now remember what I said, this is actually a two-parter. Tomorrow we're going to learn about Cramer's rule, and so you'll actually add a few problems to this.